All right, everybody. So today we're going to be talking about a new subject of linear equations. We've talked about linear equations before, but we saw equations with one variable. For example, we saw first-degree equations with one variable, something in the form of ax plus b equals c. Okay, so there's only one variable here, x. Okay, and we learn how to solve these in different forms and everything. Today we're going to see, as an example of this, let's say 2x minus 4 equals 8. Okay, and we learn how to solve this type of equation. But today we're going to see another type of linear equations, but instead of just one variable, we're going to have two, x and y. So this is one variable, but in two variables, so linear equations. Okay, so linear equations in two variables. And the standard form is there's always some, for example, some ax plus some by equals some number here, c. As you can see, we have two variables. We have x and y. A, b, c are just real numbers. Could be negatives, positives, fractions, decimals, any sorts of real numbers that we talked about before. Okay, so what makes this linear again is because the powers here are 1 on 1. Just like here, what makes this linear is the power of the x, which is 1. Another reason why we call this linear is because this actually represents a straight line. On a graph, this equation, when we graph it, it's going to look like this, a straight line on a graph. So that's what we call these linear equations. We're going to talk about in detail how to graph these and how to check solutions for these. So basically by graphing them, we actually, the line is the solution to the equation. So we're going to see how to graph linear equations later. Okay, so that's what this class is all about. And the next two classes, I believe at least two classes, will also be dealing with linear equations a lot. In this form here, and we have other forms we're going to discuss later in this semester. Okay, so that's basically what a linear equation is. Now we're going to see how to, like I said, I mentioned solutions. So the solution of this equation is a straight line. And the line itself is a bunch of points. Point after point after point after point. It's an unlimited number of points. That's what a straight line is. It's not a segment. It doesn't end here. It keeps going, expanding and extending in both directions. And each point from here on this graph has two coordinates, has x and y. Okay, x and y, another x and y, and so on. So many. So all the points basically of this line are solutions to this equation, for example, this standard equation. So in this case, we have so many solutions. Unlike these usually have one solution or sometimes none, sometimes have many. But most of the time, there was only one solution, x equals something. Okay, for example here, so x equals something. But for this, when we have two variables, the graph is a line, and each point of that line is considered a solution to this equation. Let's see how that works. But let's say I'm going to make an equation and check some pairs and see if they're solutions.
I can't. I don't know what happened.
I'm sorry, repeat that?
Oh, I can hear you now. No, I couldn't hear you before for a second.
Okay, all right. So solutions to linear equations. Okay, so let's, for example, take this simple. As you can see here, so this is a linear equation with two variables in this standard form. So if this one has solutions, they are a bunch of order pairs, a bunch of points that belong to a line. So let's check a random pair here, maybe it's 2 and 3. So we say is 2, 3, this pair, which has two values x and y, are these solution, or is this pair a solution to this line? We don't know yet. So to find out, we're going to plug these into the equation and see if that works. So x is 2, so we're going to say 2 plus y, which is here, 3. And we say, is it equal to, we don't know yet, is it equal to 7? Obviously, that's 5, that's 7. So 5 not equal to 7. So the pair, this one, not a solution. Not a solution to this equation because it doesn't check when we plug it, just like we did before with first degree linear equations. After we solve, we check our solution, see if we get two equal sides. If not, something is wrong. Same thing here. We have a pair, we plug it and see if that pair is a solution. So that's one. Now let's check another pair. This time we're going to check maybe 5 and 2. We don't know yet, is it a solution or not? So to find out, we're going to plug this pair again. First value is always x, the second value is y. So we're going to plug those into this equation and see if we get two equal sides. So x is here, is 5, so 5 plus 2, x is 5, y is 2, so x plus y. And again, we say is it equal to 7. So if we simplify, of course, 7 is equal to 7, and that checks. So therefore, this pair is a solution. So 5, 2 is a solution. Okay, so this one is a solution to this. So basically, this point here belongs to the line. Let's say if this was the line that represents this equation, we're going to see later how to graph lines. If this was the line, then this point belongs on the line, for example, belongs here. This point here. But this one does not belong to the line. It's not part of the solution, it will be somewhere here, either here or there, but it's not on the line because it's not a solution. So basically the solution to this equation here is all the points that belong to the equation of this line. So for example, this one here belongs to the line, but this one does not belong. That's a quick idea of what a solution of a linear equation is and what does it represent graphically. So you will be given pairs to check, okay? Given a few pairs to check, and then after you check them, some of them can be solutions, others cannot. And this could be as simple as this, or it might be something more. It's not always this simple. It could be, for example, 2x plus, let's say, 3y equals maybe 5. Same way, so let's check a couple of points. So we're going to check, let's say, maybe 1 and negative 2. And I'm going to check another point, possibly 2. Oh, I mean 1 and 1. Both these are possible solutions, but to find out, we're going to check them by plugging them into the equation one by one. Let's start with the first one. So 1 minus 2. So again, you just have to plug x and y. This pair here is always x and y. plug them here and see what happens. So 2 times, just like we did with the algebraic expressions when we evaluated them before the midterm. It's quite similar here, so we just plug in these carefully. So 2 times x, so put 2, some empty parentheses for x, and the x here is 1, and plus 3 times y. Again, just put some empty parentheses for y, 3 times y, and y goes here, that's -2. And again, we say, is it equal to? We don't know yet, that's why we have to put that question mark here. Is it equal to 5? So this is 2 plus or minus -6. Is it equal to 5? Obviously not. 2 take away 6, that's -4. That's obviously not equal to 5. Okay, so what do you say about this pair?
That is not a solution.
Exactly. So this one is not a solution to this equation, meaning it's not belonging to the line. Whatever the line of this looks like, this point is not on that line. It's off that line. Not a solution. Not a solution. Now let's check the second pair, which is 1, 1. Same way. We're going to plug both x and y are 1. We're going to plug those here. Again, put some empty parentheses. So add 2 times x plus 3 times y equals 5. Or, we don't know yet. We're going to see if it's equal to 5. So 1 here, x is 1, y is also 1. 2 plus 3 is equal to 5. Yes, of course. And that checks. So that's a solution. This is not a solution. So this is a solution, and it belongs to the line. The line representing this linear equation. That's why we call it linear, because its graph is a line, straight line. So a solution. So 1, 1 is a point belongs to the line of this linear equation here. Okay, so that's basically how you check whether a point or an ordered pair is a solution to a linear equation or not. Okay, so now we'll see what happens when you have incomplete pairs. So give you an equation, give you pairs, but with one value and the other one missing. For example, give you the x, missing the y, or we'll give you the y, missing the x. We're going to see how to complete those pairs based on this equation. So that would be number 3. We call that completing pairs. Any questions about any of this so far?
I don't have any questions.
Okay.
So far, I can understand.
All right. So completing pairs. Let's take a simple equation here, maybe x minus y, maybe -4. Let's say give you these incomplete pairs. Let's say 1 and the y is missing, then maybe -2 here. The x is missing, and maybe another one, 0, and the y is missing. You need to find all these missing values to complete these. Actually, let's, so here we have the y missing. Let's actually put this here instead. let's say here we have the y, but we don't have the x. Okay, so if you have a line and you have some incomplete pairs, we can complete them using this straight line. It's very simple. So let's do the first one. So we need to find the y. So basically, all you have to do is, again, as we said before, this is the x, this is the y. So we're going to plug what we have into the equation and find the missing one. For example, here we know this, we have it, it's 1, so we're going to plug it here. We don't know the y, so that stays here. And once we substitute 1, we can easily solve the other, just like we did with linear equations in the first term. Before the midterm, we learned how to solve linear equations with one variable. Today we have two variables, that's why we have to plug one. We have to be given one to plug it into the equation and find the other. So 1, the x is 1, so we're going to put 1 minus y. We don't know y, that's why it stays here, so we're going to need it to stay there to solve for it. And then complete the rest of the equation. And simply solve, so here we subtract 1, subtract 1. So 1 minus 1 is 0, we have negative y. So negative 4 minus 1 is negative 5. Finally, divide by negative 1, divide by negative 1, because there's an invisible negative 1 here. Negative 1 divide negative 1, cancel out, so we have 5. So that's the missing value here. So that point belongs to the line, because we had one value, one coordinate, we plugged it, we found the other one. So if you draw the line of this equation, this is definitely belongs to this. And these also, once we complete them, it must belong to this line. Now, the second point is missing the x. We have the y, missing the x, unlike this one. So we're gonna have to, so this is the x, this is the y. So again, back to the equation. We don't have x, so it stays there. Minus, again, always put some empty parentheses for the variable, or x or y. So this time y is 2, so we're going to put 2. Be careful, you may have a double negative. If you had a negative here, then you would put it here in addition to the negative that's already from the equation. Equals minus 4. As you can see, equation with one variable, we can easily solve it. So x minus 2 equals negative 4. Add 2 to both sides. Add 2. So x is, these cancel, x is negative 2. Okay, and this negative 2 goes here. And finally, sometimes when you have 0 here on x or y, it's easier than any other point because basically that cancels one of the variables immediately. For example, x here is 0. If you plug that here, this whole thing cancels out immediately. What you end up with is just negative y equals negative 4. Same thing if you have x here, x in the y, that cancels this immediately, and you have one variable left. This is very useful. We're going to see, we're going to be using this a lot later, especially when you graph lines. We prefer to use the zeros because they're easy and they cancel one of the variables immediately. Unlike these, you have to plug and simplify, but these, they just get rid of one of the variables right away. So let's find the other third pair here. Let's complete it. So x and y. And we're going to plug that into this equation. So x is given is 0 minus the y, which we don't know, and equals negative 4. Again, this goes away. 0 times anything. Even if you had 2x here or 5x or whatever, if you put 0 next to it, this cancels out. So that's gone. Just negative y left. And -4. And if you divide both sides by -1, you end up with y equals 5. That's the final point. Okay, so we completed these pairs, and this one was -2. Another way of writing these order pairs is to put them in a table. You can make a table like this. One column is for the x values, the other one over the y values, and just fill in the table. So 1 and 5. So 1 here and 5, -2. And 2, then you have 0 and 5. And so on. It's nicer to have to gather all these points in one table like this. So you might be given pairs in form, or you might be given a table with missing numbers that you need to complete. For example, like this table without this value, for example, or without, let's say, this value, maybe without this value. So it could look something like this. Okay, just like that. Give you pairs incomplete, or put them in a table. So you need to find this one, for example, then find this x here. And for this one, we have x, we need the y, and so on. So either form is fine. So let's put these back. So we found out that this is 5. And number that was missing here was -2. And here the value that was missing was the y, which is 5. Okay, so you might be given an incomplete table like this, or some incomplete pairs like these. But the way we complete them is similar. Just plug what you have and solve for the other one to get your table. Okay, so all these, by the way, are points. So each one is a pair of order pair with an x and y coordinate. And if you plug these, they will look like this. So you put them on a graph. We're going to see how to graph later. They must belong to the same line because all these pairs came from here. When you graph them, they must belong to the same line like this. If they don't, then there is something wrong. You can't have points like this. No, this is a linear equation. These points belong to that line, to this equation. So another way of checking that you got the right pairs is by graphing them. The question will sometimes ask you to graph. So it will ask you to complete and graph. So if your points don't end up on the same line, that means there's something wrong. But in this case, these points here, let's assume everything is fine. And we'll see how to graph that later. Now, actually, let's see how to turn this into a straight line. Okay, let's see how to put these points in a graph, and hopefully they must end up straight on the same line. Otherwise, there's something wrong. So that's the next part. That's plotting or graphing order points. So number 4. So plot is when you put points on a graph. You take these pairs and you put them on a graph. That's what we call plotting. Plotting ordered. Let me write it again. Then ordered pairs. So again, each one of these makes an ordered pair with the x and y coordinate. Let's take the same one, same example here, and put these into a graph and see how they end up on a line. So we have 3 of them. We have 1 and 5, -2 and 2, and 0, 5. So to graph these, we need a graph, an empty graph, which consists of 2 two axes. We have the x-axis and we have the y-axis, because we have two variables. Basically, we have two dimensions in this graph. One, the horizontal one, is always for the x value, or the first value of each pair. Second value represents the y coordinate, so this is the x-axis. And the y-axis. Okay, so to locate a point on a graph, we need two values. We need the x and the y coordinate, just like these. This is what we call an ordered pair. Basically, to locate any point on a graph, we need an intersection, just like with a map, for example, of Manhattan. So we have streets that go like this, and we have avenues that go vertically. So to locate any intersection or any point on this map, for example, you need two streets. Let's say if this was, I don't know, let's say 10th Street here, for example, 10, 11, 12, 13, and 14. These are streets, and these are avenues. Let's say First Ave, okay, second, third, and fourth. So when you meet someone or you want to go to a place, it's usually sometimes it's on the corner or the intersection of the streets. So if you want to, let's say, tell someone to meet you over here, what would be the order pair of this point on this map? Let's say this is a Manhattan map, and you want to go exactly to this location. You want to meet someone there. What are the coordinates? What's the order pair of this specific intersection here?
Between Second Avenue and 13th?
That's right. So Second Avenue, these are streets.
And 13th Street.
That's right. We start with the x coordinate, which is on this axis. So in here we have the x, or here the x. So Second Avenue and all the way to 13th Street. So that's this point for location on a map. That's basically how this works to the graphs. There's always an intersection of x and y. This is generic. X could be a name of street or avenue or something. Same thing here. This is an actual example. And this is basically how Google Maps work. Google has a GPS service or map, and each point on Earth has its coordinate. So everywhere on Earth, there is a specific coordinate for that location with X and Y. Okay, so now let's see how to put these into this graph. So you can easily make you a graph, or you can use graphing paper. You can print it out from the internet easily. So we have some positive values here. So 0, and we have 1, 2, 3. So these, so the x-axis here, just like we saw with the number line before, the values here are positive. The values to the left of 0 are negative. -1, -2, -3. Same thing with the y. So it starts from 0 here and it goes up. So these are positive. And below here, below 0, the values of y are negative. So -1, -2, -3, and so on. Now we're going to see how to put these values into this graph. So again, we know that each pair has two values. The first one is always the x, the second one is always the y. Okay, so when you graph this, you first locate this x value on the x-axis, the horizontal axis. Once you find it, then you go to the y. From this, you go to the y, either up or down only. Okay, the y is vertical. So once you find the x, from here you can either go up if it's positive, you go down if it's negative. If it's 0, then you don't go anywhere, you stay right on this value here. But in this case, so the x is 1. So let's find that. It's positive. It's going to be here. From here, we're going to go up. From this point, the x, we're going to go up 5 points because the y is positive. So we have 1, 2, 3. This is 4. This is 5. So start from here, go up 5 units. Start from the x. We got 1, 2, 3, 4, 5. All the way here. So that's this point. Okay, let's call this, let's say, maybe A. The second point, you do the same thing. You start from -2, then you go to the y. So this is the x. Always locate this here on this axis. In this case, it's negative, so it's going to be on the left side of 0, which is here. So that's -2. From here, we're going to go up again 2 units. If this was negative, we would go down. We're going to start from -2, go up 2 units. Okay, so let's call this point B. Finally, 0, 5. The x is 0. Where would 0 be again here on this graph?
In the middle?
That's right. In the middle of the graph, in the center, both x and y are 0 here. So we're going to start from 0. Then we're going to go up 5 units. Start from 0, which is right in the middle here, and go vertically, not to the right, not to the left, vertically from here, 5 units. From here, 1, 2, 3, 4, all the way to 5. Okay, let's double check again. It looks like our scale is off a little bit. It's not exactly drawn to scale. So there's a problem here, as you can see. So these points, they don't belong to the same line. But they should. They have to belong to the same line. I didn't draw the line correctly, or I didn't make the graph correctly. But let me use an actual graph. Let's find, okay, I'm going to try an actual graph and see if the lines are aligned, or the points are aligned. So if you have graphing paper, it's better to use it. If you have to draw your own graph, you need to make sure these lines end up aligned. So let's first double check these points here. So 1 and 5, so we start from 1, we went to 5. And then -2 and 2. Start from -2, we went up to 2, which is here. So these two so far look pretty good. Then 0, 5. So 0 is here. 5 looks a little bit off the line. So let's go back. There's probably this one is something wrong with it. Let's double check the signs again. So we plugged 0 in the x. So -y minus 4. We divide by -1, -1. So this one looks okay. Let's double check the other one. So we had y minus 4, or x minus y equals -4. We had the y was given, which is 2, plus 2 plus 2 minus 2. So -2, -2 looks fine. And the first point was 1 minus y, so we plugged -1 here, divided. So these points look okay, so everything looks fine here. We just need a...
I have a question.
Go ahead.
So for the point 0 and 5, if we do -4 divided by -1, will we get 4?
Oh, that's what it was. Exactly. So that's what it was. It should be what here? It should be what again?
It should be 4.
Exactly. Okay, so that's again why I said earlier, these points must be on the same line. If they're not aligned, there is something wrong, and that's what was wrong here. So this should be a 4. Now it's going to look exactly like a straight line, as you can see. So instead, so here from 0 to 4. So I'm going to start from 0 and go 1, 2, 3, 4. I will be exactly here. As you can see, that's a completely straight line, just like this, almost, as I said earlier. This 5 was off the line. So let's take that off. Okay, so the line, you can go ahead and draw it now. Let me see if we can find a straight line here. There we go, it's right here. Okay, so once you have all your points, you draw the line like that. Better yet, if we use a straight line. Let's try again. Okay, so it's better if you use a ruler and graphic paper for this kind of lines. So that looks great, looks perfect. As you can see all the points, 1, 2, 3, not this one. It's not part of the line. They look linear, and that's the purpose. And that's basically what we expect when you graph a linear equation, because it's gotta be a straight line. If you get something that's weird, like we did earlier, that means something is wrong, we go back and double check everything. And always take at least 3 points. That's how you know. So when you have 3 points, the third point is like a check. Third point is usually used as a check. Because when you have 3 points, they must all be on the same line. So there's a very small chance that you get all of them wrong and they still end up on the same line. Okay, there's a very, very small chance that, let's say, we get all these wrong and they still end up on the same line. But if you do only 2 points, let's say you only completed 2 pairs and you end up like this, there's no way to check whether these are right or wrong. So if you have 2 points, maybe this one is wrong, maybe it could have been here or here or here, but it's still just one line. You can draw it anywhere you want. But with 3 points, you can't go wrong. With 3 points, they either belong to the same line. If not, something is wrong. So when you graph a line, if you have ordered pairs, you may have ordered pairs. If you don't have ordered pairs, you can make up your own like this. You can make up a little table. Try to use at least 3 points. So that way, the third point is a check, just like we did earlier here. Because this one was off the line, that means something was wrong. So after double checking, we found out where the mistake is. Okay, so again, this is what we call checkpoint. Third one, even though 2 are enough, but again, they don't tell us whether we got it right or wrong. So we have to do at least 3 points. Okay, that makes sense. Any questions so far?
No.
No.
All right, so what else? Let's see. That's right, so we're just gonna do one more thing. It's basically how we graph lines. We're probably gonna do another example. But before we do that, let's see, I want to talk about another thing here. Okay, let's do one more example. I'm gonna start, I'm gonna do everything again from scratch. Take another equation and we're gonna graph it and find something called the intercepts. Okay, we're gonna talk about something called the intercepts. Basically, where the line, our line, where it meets the other 2 axes from the graph. the x-axis and the y-axis. So the intercept are these. This is one intercept, and this is another one. So what we call the y-intercept, as you can see, because that's where the y-axis meets our graph, so we call it y-intercept. The other one, because the x-axis meets the line here, we call that the x-intercept. So that's what we're going to see here next. What are the coordinates again of this point? X, the y-intercept. So the x was 0, and the y is 4. For this one, what is the x here? If you look at the graph, -3. Then
Zero.
negative.
Negative.
Is the x, and what's the y at this point?
0.
That's right. If you drop it over the y-axis, it's 0. So here's what's important about these intercepts. There's always a 0 in them. The y-intercept is always 0 on the x. Okay? The y-intercept, the x is 0. Okay? Not the other way around. The y-intercept, there's always a 0 here. You just find the intercept on the y. For the x-intercept, there's always 0 on the y. Okay, these are very specific points, very special points, as I mentioned earlier when we did the pairs. It's always quite interesting and easy to use the zeros either here or here. So that's what gives us the intercepts. So remember, the y-intercept, it just means the x is 0, and from that you can find the y by plugging the x 0 into the equation, any equation, and you find the other one. And the x-intercept immediately puts 0 on the y. And you can find this, if you don't have it, you can easily find it by plugging 0 into the equation. So let's do a graph, let's do another one, by finding the intercepts, both intercepts. So if you can find both intercepts and you can find them correctly, you're pretty much done. You just need to draw the line between them. And these are easy because they cancel one of the variables right away. So once you find the intercept, you pretty much have the line. But to make sure you got the right line, we add another checkpoint. Just choose another random point, maybe x1 or y1, and complete it, another pair. Just like we did earlier here, always add a third one to check. So we're gonna call this intercepts. So x and y intercepts. X and y intercepts. Let's take this equation here, maybe -2x plus 4y, maybe 8 here. A lot of times the question would ask you to find or the intercepts. So finding x and y intercepts. We're going to refer to this from now on as int, as in intercept, so x and y intercepts. So to do this, here's what you do. It's pretty simple. You have a little table like this. So you put x and y as always. So one row for x-intercept, the other one for the y-intercept. Let's start with the first one. Let's make this the x-intercept. Let's make the second point the y-intercept. Okay, what does x-intercept mean again? Which one is 0? The point x-intercept. Which one of these is 0? If you look at
the x-intercept, it will be -4.
No, when you say x-intercept, which one of these is 0? Which one of the x or y is 0?
Oh,
It's y.
Y
The
is 0.
Y. Oh, 0. Okay, yeah. Y.
X-intercept always means the Y is 0. So we're going to put the Y 0 here, and then we're going to figure out the other one. On the Y-intercept, it means that X is 0. On the Y-intercept means that X is 0. Y, as you can see, any point on this line, its X is always 0. That's why we put 0 here. So most of the time, the question will ask you to find the intercepts. That's what it means. When it says find the intercepts, you just do this little table. X-intercept, put the 0 here. Y-intercept, put the 0 under the X, and just fill them up. Find these values. So let's do that. Let's complete this one here. So Y is 0. If you put Y here, this cancels, right? So when you plug 0 into the equation, the term with the 0 cancels out. So Y is 0. If you put 0 here, this cancels. It will be negative 2x plus 4 times 0. Okay, because that's the x-intercept, and the x-intercept means the y is 0. So that's gone. You don't even have to write it. You can just ignore it. Just write this equals negative 8, negative 2x equals 8. And if you divide by negative 2x is negative 4. Okay, so this is negative 4 here. Then the other intercept, we're going to do the same thing. So this time, the x is 0. So for the y-intercept, the x is 0. That means this cancels out because 0 times anything cancels it out. So that goes away. Just have positive 4y left. Okay, so the x is 0. It goes here. That cancels this term. You can have 4y, positive 4y is 8. If you divide both sides by 4, we get y 2. The missing value here is 2. But we're not done yet. We could have made a mistake here easily, like we did earlier. So we're going to have to add a checkpoint. We have to add a third point just to check. When you add a third point, it makes it very unlikely that you made a mistake. So if you don't get these 3 on the same line, obviously there's something wrong, you have to fix it. But there's a very slim chance that you get all these wrong and somehow they end up on the same line. It's 3 wrongs will not make it right, or at least there's a very, very small chance that might happen. And for the third point, it's up to you. You can choose any points. Go with something small, 1 or negative 1. Since we already used the 0, so start with some 1 or 2. If you get a fraction here with 1 or 2, maybe choose another number. Just look at the equation and see, and try to use a convenient number. For now, let me use probably maybe x1 or x negative 1 actually. It doesn't actually matter, so let's just make it positive. And let's find this value here. Again, this is the third point to check. So the x is 1, I'm going to plug that here, so negative 2 times 1 plus, we don't know the y. We're looking for it, it's got to stay there. Then solve this to find y, so this is negative 2 plus 4y, and we have 8. If you add 2 here, so we end up with 4y and 10. Okay, so this number might not be as convenient as I said earlier. So it will give you probably a fraction. If you divide by 4, so y will be 10 over 4. Okay, so might not be the best number. So what if we tried 2 here? If we tried 2, it would be 2 times 2, which is 4, so negative 4. End up with 12, still the same thing. But if we do negative 2, would be, let's see, negative would be 4, 12. It will still be a fraction. Let's use 4 here. So if you use 4, would be 2 times 4. Okay, that would be 8. Okay, let's use 4. This is still good, but it's a fraction, so you probably don't want to deal with a fraction. Let's instead use.
Can we change it to a decimal?
You could change to a decimal. To graph it, you can still probably graph a decimal here, but maybe try to use whole numbers. Maybe they're probably easier to graph. But you can use a decimal for sure. Let's try 4 here. Let's try, for example, 4 in this equation. So again, if we use 4, it will be -8. Okay, 4 might work. So we plug 4 here, it would be -2 times 4 plus 4y equals 8. So -8 plus 4y was 8. If you add 8 here to both sides, you get 4y plus 16. If you divide by 4, y will be 4. So that's better. Okay, 4 is a better number, better than the decimal. All right, so now we have our table. So hopefully, again, if we're correct, all these must end up on the same line without a problem. So this is what we use as a checkpoint. So let's make a graph, quick graph here. The x-axis, the y-axis. And so I'm going to try to be as accurate as possible with the graph. If the scale or the unit is not the same, the graph might not look good. So approximately something like this. Again, you can always use graphing paper. -4 and 0. So -4 is 0, 1, 2, 3, 4. So -4 and the y is 0. So we start from here, where do you go? If you start from this point, where do you go? Start from x and the y is 0. Do we go up or down or what?
No, you just stay where you are.
You start from the circle.
Exactly. Start from x is here. But since the y is 0, it means we're not going anywhere. Usually we'd go up or down, but if it's series, stay right over here. Then we have 0, 2. So we're going to start from x0, which is in the middle. Where do you go from there?
You go up 2 times.
Exactly. Start from here, go up because it's positive. So 1, 2. So this is -2. And the third point, start from 4 and go to 4, go up. 4 will be 1, 2, 3, 4 here. 1, 2, 3, 4. And go up to 4 from here. So 1, 2, 3, 4 will be here. Let's see how this ends up. So we're gonna start from 4 again and go all the way to 4 on the y. So it'll be from here, go all the way to 4. How does the line look like?
Yeah, it looks great.
Looks straight like this. If one of the points ends up of the line, you gotta double check the signs here. There's a lot of room for a mistake here. You could have missed a sign or missed something. So you gotta double check. And finally, grab your ruler and you join those points together. Let me see here. And make sure your line is straight like this. And that's the line that represents, okay, so this equation here is basically this line. So the solution set is a line. Okay, so for this line, any point that belongs, for this equation, any point that belongs to this line, there's so many of them, infinitely many, any point is a solution to this, because if you plug it, as we did earlier when we checked these against the equation, if you take any point from this, each point has x and y coordinate, which you can read easily from the line. When you plug that into the equation, it will definitely check out, because each one of these is supposed to be a solution to that equation. Okay, so remember the x and y coordinates, I mean the x and y intercepts. Whenever you hear x-intercept, it just means the y is 0. So this is the, again, the y-intercept, and this is the x-intercept, because the x on the line made here. So this is the x-intercept. As you can see, the point is, for the x-intercept, the y is always 0. So the y here is always 0. So 0, -4. And this is the y on the line, so this is what we call the y-intercept. For the y-intercept again, the x is always 0. So the x is always 0. The y is whatever you see here, that's -2. That's what we call the y-intercept. Okay, does that make sense? Any questions, confusions?
I don't have any questions.
Okay, so I know this probably was a lot of information. I suggest that you rewatch this so you could stick even stronger. So we're going to be talking more about lines in the next 2-3 classes. Will be based on this. All the concepts we learned today, we're going to be using them next 2 to 3 classes. So make sure you review this. As you do your homework, go over this again. So to recap again, so this is linear equation with variables. It's a straight line. We can do a lot with it. We can either check a pair if it's a solution. We can complete a pair if we have one of the values, x or y. Once you complete those pairs, we can plot them. We can put them on a graph to find the line of the graph or the direction of the line of the graph. And the line represents the solution set. All the points that belong to that line will satisfy or validate this equation if you plug any other pair from here into the equation. And remember the x and y intercept, they're good. They're easy because they cancel out one of the variables immediately. And in addition to that, you do want to add another point just to be on the safe side. Otherwise, you wouldn't know whether you made a mistake or not. For example, earlier, if we didn't use a third point here, if we used only these, and they ended up like that, one was here, the other one was there, we didn't have any idea. We wouldn't have, or we wouldn't know if we made a mistake or not. We wouldn't have known if we made a mistake or not if it wasn't for this, had we not added a third point. So because that point looked suspicious, that made us double check and we find out that there was something wrong. So usually 2 points are enough, but it's not good enough to be sure that the line, you get the right line. So you do want to add third point just to be on the safe side and as a checkpoint. All right, that does it for today. I'll post this along with the homework sometime soon.